Okay, in this video, we are going to be working with inverse function, and we're actually going to solve two problems. But first, I'm going to show you the procedure. So there's 4 steps. I recommend these 4 steps. First step that I recommend says replace f of x with y for the original equation. And this will make more sense when we actually do a problem. Second step says replace every x with a y and replace every y with an x for a new equation. Third step says solve the new equation because we want to isolate the new y value. And the last step says replace y with this inverse symbol right here. And so we're going to solve this first problem. And we're going to use our 4 steps. So step 1 said replace f of x with y, the original equation. So this is our original equation, and it has an f of x. Our first step in our procedure says replace f of x with a regular y. So we're going to say y is equal to 3x minus 4. That's step 1. Now, step 2 says replace every x with a y and replace every y with an x for a new equation. So what we're going to do is, instead of having a y, change it to an x. Instead of having an x, change it to a y. And that's step 2. And I'm going to go back to our procedure just to make sure that we understand step 1 and step 2. So step 1 says replace f of x with a y for the original equation. Step 2, which we just did, says replace every x with a y and replace every y with an x for a new equation. Now our third step says solve the new equation. We want to isolate the new y value. So our third step, we want to isolate this y value here. So the way we have to do this to isolate this term, we first need to get rid of the negative 4. And the opposite of a negative is a positive. So we're going to add 4 to the right and to the left. And we're going to get x plus 4 is equal to 3y. But we're not done yet. We have a 3 times y. We don't have y by itself. So to get rid of the 3 in front of the y, we need to divide by 3 and divide by 3. And now we get y by itself because 3 divided by 3 is 1. So we get y is equal to x plus 4 divided by 3. So that was our third step, solve the new equation by getting the y by itself. Our very last step is like formality. Instead of having a y, we want to write this, f raised to negative 1 parentheses x, to represent an inverse function. And so our fourth step, mostly just a formality thing, we're going to write f raised to negative 1 parentheses x is equal to x plus 4 divided by 3. And this right here is our final answer. And we're going to do another problem. All right, this is the last problem. We want to do the exact same thing, find the inverse of the function. Again, 4 steps. First step says replace f of x with a regular y. So that's what we're going to do. And our second step says replace y with an x and replace x with a y. And that's our second step. Now our third step says we need to get this y by itself. We need to get this y by itself. We need to isolate the new y value. So we're dividing by 2, and in order to get rid of the division, we could multiply by 2. And if you do it on the right-hand side, you also need to put it on the left-hand side. And so we would get x times 2 is equal to y plus 1. But we're not done yet. We don't have y by itself, so we could subtract 1 on both sides. So we would get y is equal to, now this is saying x times 2. That's the same thing as saying 2x. Usually you want to have the number in front of the variable. That's what people typically like to have. So that's what we're going to do, 2x. And now we have a minus 1. And our very last step says replace y with the inverse symbol. So we can say f raised to negative 1 parentheses x close parentheses is equal to 2x minus 1. And this right here is our final answer. Again, a recap, first step says replace f of x with a regular y for the original equation. Second step says replace every x with a y and replace every y with an x for a new equation. Third step says solve the new equation by isolating the new y value. And the fourth step, mostly just a formality, change the y with the f raised to negative 1 parentheses x. And that's pretty much it. regarding inverse functions.